Alright, so I wanted to show, this is going to be a bit of a shorter one, but I wanted to show you something kind of neat that I came up with. Um, my wife had purchased a, it's a, it's a bathroom scrubber. I don't know, it's a long wand, it's got a motor in it, and you put different brush heads on it, and you use it to scrub different things in your bathroom. You know, your toilet, your tub, what have you. So it worked pretty good for a little while, and then it burnt out. It quit. And one day she asked me, "Can I fix it?" And like any good husband, you know, she had to remind me 6 months later, "Can I fix it?" So finally got around to fixing it, and I wanted to show you what I did because it didn't really just fix it. I ended up kind of modifying it and making it work a little bit better than it did. Let me show you the scrubber. It's kind of long, so I'm gonna have to kind of give you like a long shot here. But here's the base. You've got a switch on off. Then it comes apart in sections. It's got a clip here. It's got the main shaft, and then it's got this section here where the head comes off as well. So I'm going to go ahead and pull this apart real quick, and then I'm going to show you what was broken, and then I'm going to show you how I fixed it. So stick with me and I'll pull this apart real quick. Okay, so here's the end taken apart. Let me go ahead and move some of this out of the way. Here's the main section taken apart. And I'll show you real quick. This here is the main control board for it. Sorry if you can hear my fridge. My fridge just kicked on. Anyway, this here is the main control board. Let me see if I can get this. Oh, I think it's clamped in. I'm going to get this up real quick. Have to speed through this one. How did I get this out in the beginning? No, there we go. Okay. Disconnect these. Alright, set this aside. So here's the main control board. As you can see, it's got spots where components would be populated. Originally, when I took this apart, a couple of the components, specifically on the back end, had completely burnt up. Completely. So, I could have gone the easy route and just figured out what these components were, purchased them through a DigiKey, mouse, or what have you. Wait a few days and replace them and call it a day. The problem I have with that is if they're blowing up, it means that they're either not of good value or it's a poor design to start with. Doing some diagnosis of the design, I ended up really realizing not only was it a poor design, it was poor components as well. I think she paid like $30 for the whole kit, so it wasn't very expensive. So what I ended up doing, and I'll show you here, I ended pretty much ended up leaving all the connectors on, but then I depopulated everything. So you see everywhere where there's a solder connection, everything's been removed. And except for, of course, the connectors. And the second thing is what I did was I ended up just jumping some connections straight over, and I'll explain to you why I did that. The reason being, and I'll set this down, is the second part. The other thing that showed me that this was very cheaply made was originally in this there was one single 18650 lithium cell. For those of you who don't know what 18650 cells are, pretty much most technology out there that uses any kind of batteries uses most types of lithium cells, whether they're flat pack, but most like laptop batteries, anything especially with any kind of girth to it, is going to be comprised of either 18650 or similar cells. And it basically looks like a AA battery, only a little bit longer and a little bit thicker. AA is running like 1.25 volts. 18650s are rated for between 3.7 and full charge for 4.02 volts, something like that. I'm sure I'll have to correct myself here. But anyway, this only had one 18650 cell. So it didn't last very long on a single charge, and she'd get maybe a clean and a half before she'd have to charge it. And with the components in it, it'd take forever for it to charge. So I knew I wanted to upgrade the design, and I wanted to make it last longer. And I'll show you what I ended up doing here. Let me see. Where did I put? All right, sorry about that short break there. Had to go find. I had some spares, but anyway, what I ended up doing, I'll show you what these are in a minute. But what I ended up doing is, I have a rather growing stash of 18650 cells, from lots of old laptop batteries. I used to own a computer repair business, so I have a lot of old batteries. Fun fact. Laptop batteries, when they go bad, they don't actually go bad. What happens is usually one cell within the mix goes bad. The onboard, brain, so to speak, the controller, the battery management says, "Hey, this cell is bad. Therefore, this laptop is no longer going to charge, or this battery is no longer going to charge." Is usually what happens. It's not very often that every cell fails. They're fixable, however. Anyway, beyond the point. So what I ended up doing, getting back into it here, as you can probably make out here, and I kind of ended up taping this just because I didn't want this to move, but I have two of these cells in here. So I replaced the two cells with, or I replaced the one cell, pardon me, with two. The second thing is 18650 cells on their own require that they A, not be overcharged, and B, not be undercharged. And so on their own, cells don't have any kind of management system to do that. This board originally had the componentry to do that, however they burnt out. So I needed to figure out a way of getting these cells to charge and to drain without under draining or over draining, I guess I should say, properly. So what I ended up finding, after doing a little bit of looking online, eBay, Amazon, and whatnot, I ended up finding these. And what these are individual one-cell battery management systems for 18650 cells. And I think I got like a pack of 10 of them for like $2. They're ridiculously cheap. And it's real simple. As you see, they've got your nickel strips on them. So these come ready to be affixed to your cell, whether you and the proper way is to do a spot weld. I don't have a spot welder. I don't feel like making a spot welder. I don't feel like finding somebody who's got a broken microwave to make a spot welder. I'm not gonna do it. Can't make me. Whatever. I soldered them on. They're fine, but these two have one of these each soldered on to using the nickel cells, and then I connected these two in parallel, and that's important. You do not want these in series. A number of reasons. One of them is that the motor built in isn't able to provide the voltage that runs. The motor is built for like a 5-volt max. These would be running at about 8 volts, so you're going to cause problems there. The second thing is I wanted my wife to be able to have longer running, and that's the most important thing, is that having these in parallel instead of series allows me to run twice the output watt hours and keep the same voltage, which makes it really, really simple. So because I modified it, I'm glad, because now using this design, my wife is able to get many more cleanings out of this. She can go probably months without having to charge this guy now. And that's the other nice thing about these management little systems, is that they do a good job at keeping any kind of current from leaking, from any kind of leakage current from happening on these cells, which is really, really nice. So we don't have to go very long. We don't have to recharge it every couple of weeks. In fact, I think when I fixed this like 6 months ago, I think I've charged it one time since then, and it still works great. So that's my design. That's what I came up with. I'll go ahead and put it back together real quick, and I'll show you what it looks like. Again, kind of fully assembled, and I'll put the little brush head on. So let me do that, and I'll show you how it works. All right, as Big Clev would say, job done. So here's the unit put back together. As you can see, it's quite long. It's bigger than my camera lens can see. So I'll kind of give you just a kind of quick little pass through. But here's the main unit. It's got a not waterproof, but water resistant cap over the charge port. Let me see if I can get a good angle for you there. There's the charge port. There's the charging status LED, which I will hook back up eventually. I have it disconnected for now, but I will have a circuit in there to show the charging status. And that's the other thing is that, in order to charge this guy, because it doesn't have any kind of status LED on it yet, really it's just a simple matter of plugging it in at night before you go to bed. And when you wake up in the morning, it's charged. This BMS is doing a job at keeping them from getting overcharged, so you don't have to worry about that. So anyway, here's the base. You come down here, shaft, and then it's pretty neat. It uses these little kind of scrubby heads here, and they just attach right on. Turn it on, and now it's spinning. So anyway, there it is. There is my repaired and modified cheap Amazon bathroom scrubber. If you care, I'll put a link in the description. Just put a comment, and I'll show you where it's at. Otherwise, feel free to check out my other video if you haven't seen it yet already. I'll probably end up making some more of these. I kind of like doing this. Kind of fills my free time when my son's sleeping. So sorry about the first video. For those of you who have seen it, I realize it's a little bit long, and I realize my son's making a lot of noise, and it's probably not great for those who are wearing headphones. It's a little loud. I apologize about that. I will do my due diligence to make sure that he's either in bed or well pacified when I'm making this video, so you don't have to worry about getting loud bangs in your ears. So anyway, thank you for watching. Like, comment, subscribe, do all the fun things if you care. You don't have to. This is like my second video, so whatever. But I hope you enjoyed that, and look forward to more cool things to come. Have a great day.